All right, let's do number 8 on the back of the review sheet. It says, a Mexican jumping bean jumps with the aid of a small worm that lives inside the bean. If a bean of mass 2 grams, so we're given that mass is equal to 2 grams. Now, before I even go on and do anything else, I'm going to say to myself that grams need to be converted to kilogram, because kilogram is our basic unit, right? So when I move that, I need to move this 3 decimal places to the left. 1, 2, 3. So mass is equal to 0.002 kilograms. See how I'm chunking it? So before I even go on, I'm going to make sure I don't forget to do that conversion. It jumps 1 centimeter. So I know some height is 1 centimeter, which I'm not even sure what that is. And I need to convert the centimeters to meters. So 1, 2, this height is equal to 0.01 meters. So it says, find how much potential energy has it gained in reaching its highest point. So I want to find the potential energy, or the change in potential energy. B, what is its speed as the bean lands back in the palm of your hand? So I want to find the velocity. Now let's just look at a picture of this. So let's say your hand is the ground, or what we're going to call what? Base level, which is your frame of reference. So what happens is, this is just like the problems we did in Chapter 2. The bean goes up. It reaches its maximum height. And then when it comes back down, it's kind of like a free fall problem. You see what I mean? So you remember in the other chapter, you know, like you throw something up in the air, and then a ball, and then it comes back down? Remember that? And the time it takes to go up is the same as the time it takes to go down. So either way, so for the first part, it says, if the bean has a mass of 2 grams, how much potential energy is it gained? Well, if I'm calling the ground base level, remember, at the bottom, the potential energy I'm going to say is 0, because MGH, the height is 0. So up here at the top, I'm going to have my maximum potential energy. So the potential energy at the top is just going to be MGH. So it's going to be the mass, which is going to be 0.002 kilograms, times gravity, 9.8, times the height, which is 0.0 meters. So 0.01 times 9.8 times 0.002 equals, and it's a really, really, really tiny number. See, the calculator says 0.0000196. So then I use that fancy button behind number 5 where it says SCI. So I press second, and it puts it in scientific notation for me, which is 1.96 times 10 to the negative 4 joules. Yes. Is all energy in scientific notation? No. Usually it's expressed in correct significant figures. Which this has 3 significant figures. This has 2. This has 2. So my final answer should probably be 2, but then it would be like 2.0. Okay. I don't. See on the sheet it says 2.0 times 10 to the 4. Because correct significant figures would be 2 significant figures. So this is the answer that's on that worksheet. So that's correct significant figures. Because this has 2, and this has 2, so my final answer should have 2. So that's where the 2 comes from. So if you were doing it on your calculator, and you're like, oh, I had 1.96, because the final answer, whenever you're doing your homeworks, the answers in parentheses on the worksheet always have the correct number of significant figures. So that's why the final answer says this. Okay? All right, part B says, what is the speed as the bean lands back in the palm of your hand? Now, when it goes up and it goes down, it's the same. And, we could just work it out. So, remember, when I'm throwing it up, or when the bean jumps, that's when the velocity is going to be the greatest. So here, the potential energy is 0, or here the potential energy is a minimum, and the kinetic energy is a max. So the velocity is the greatest here, and as it's going up, gravity is pulling it down, and the velocity is going to decrease till you get to the top where what? The velocity is 0. So at the top, when the velocity is 0, the kinetic energy is a minimum because it's 0, right? And then as it falls down, here, the velocity is going to start increasing, and you're going to have the maximum here. It doesn't matter how you do it. So we'll just do conservation of energy. So first, in layman's terms, we'll write that the total energy before is equal to the total energy after. So the total energy before is going to be KEI plus PEI is equal to KEF plus PEF. Now, when we do this, we have to figure out, well, are we doing the top? Are we doing the bottom? Like, what are we doing? Are we doing going up? Or are we doing coming down? So, if it says, what is the final velocity just as it hits the ground, is that what the question says? It says, what is the speed as the bean lands back in the palm of your hand? So this is coming down. So we'll do that. So let's just look at the second half of the problem, this. So at the top here, we have potential energy. The kinetic is 0. At the bottom, the potential energy is 0. So the potential energy at the top is equal to the kinetic energy at the bottom. So the potential energy at the top, do you see how we calculated that in Part A? So I can write it. It doesn't matter. I can write mghi is equal to 1/2 mvf squared. But I already calculated this. So I'm going to take my answer, which I would use the correct significant digit one, 2.0 times 10 to the negative 4 joules, is equal to 1/2 mv squared. And now I want to solve for Vf. So I'm just now going to rearrange the equation to solve for the unknown in terms of the known. What I would do is I would probably leave it in terms of the PE. It doesn't matter. So I multiply both sides by 2. Let's leave the variable here, PEI. So I'm going to multiply both sides by 2, divide both sides by m, and then take the square root of both sides, and that'll give me Vf. Now I'll substitute in my values. 2 times 10 to the negative 4 divided by my mass, which is 0.002 kilograms. Okay? So it's just like we did before, conservation of energy. See, the thing about these problems is with the jumping bean and the conversions, it kind of throws you off because you're like, what are they talking about? Okay? And you just have to read it carefully. So, again, the whole key here, conservation of energy. The total amount of energy remains the same. So at the bottom, right before it hits the ground, it's all kinetic and no potential. And at the top, it's all potential and no kinetic. So, again, you need to know how to do one of these types of problems, or both types. We've done most of our homework problems, a lot have been like this. Either you're throwing something up in the air, or you're dropping something, or something falls to the ground. And that's it. So it's just the same thing.